All right, so this video is going to cover the Chapter 5 video on Chapter 5, Module 2, and it's all on conditionals. So basically a lot of if-else type logic. So I'll be writing code in here and doing a few other things. Now for this chapter, I'm not going to do the back of the book programs. I've already done I've already done one similar with the time exercise. And you guys can work on some of those exercises. I have different things that I've brought in that I'll demonstrate, and then you guys can look at here. But this is, let's see here. Let's change this. This is chapter 5. Okay, module 2, chapter 5. I'll just call it conditionals. All right, so the chapter starts off looking at division problems in Modulus with the remainder. So you could have a variable minutes, and we'll say that's equal to 105. And we could say print minutes divided by 60, and that would give us all right, sorry about that. Something was going on with my computer. But anyway, if I put in minutes is 105 and I print my minutes, 105 pops up. If I then divide it by 60, okay, I get 1.75. Okay, so and that basically gives me 1.75 hours. Now, you don't really want that. What you want to say is hours is going to be equal to 105. Sorry, I could say minutes divided by 60, and then I can print my hours. All right, and that's still going to give me 101.75. Now, in order to change that, I'm going to make sure that I divide this so it cuts off my remaining balance, and now I could say minutes is equal to minutes divided by 60, and let's see here. I could say hours plus, and I'm gonna make this a string real quick, plus, and then so then that gives me, whoops, sorry, I meant to do this. I meant to do remainder. So this will give me the remainder. So that gives me 1 hour, 45 minutes, okay? So this will give you the remainder of whatever you're looking for, all right? And I went through that on one of the videos, in one of the past videos, okay? So we then get into this stuff with relational operators. So let me open up, so our relational operators are relational operators. Let me make this larger. Our relational operators are greater than, less than, greater than equal to, less than equal to. Okay. You learned about these when you were in elementary school, okay? So this then gets us into what's called Boolean Expressions, and we can start looking at stuff. So we could say, if I don't know, age is greater than 21, then you can you get to go in the club, or something like that, okay? So this gets into the Boolean expressions, which then gets us into logical operators, because maybe you want to have something like and, and here's your logical operators. You got and, or, and not. Okay, so you got to be 21 and your wallet has to be greater than $10 or something like that. Both of these expressions have to be true in order for this to run. Okay, so that gets us into, I'll quickly go through truth tables. So let me open up my pen. Sketch screen, let's do that. Okay, so imagine you have a variable A and a variable B, and you've got A and B. Okay, and so A can be true and B can be true. Okay, are both A and B true in this expression? True and true is true. Okay, A can be true and B can be false. Are both of these true? So the word and means, think about it as both. Are both of these conditions true? If they are, then it's true, but since this is false, the whole thing's false. Okay, then you've got false and true, and then you got false and false. Okay, so are both of these true? Nope, so the whole thing's false. And are both of these true? Nope, so the whole thing's false. So again, these are called truth tables, and they should kind of help you think about how just basic logic works. Okay, so again, we can have, for the next one, we'll have A and B, and we'll have A or B. So we'll have same thing, true, true, whoops, that's true, true, false, false, true, false, and false. So true or true is one or the other true. Yep, so the whole thing's true. True or false is one or the other true. Yep, so the whole thing's true. False or true is one or the other true. Yep. False or false is one or the other true. No, so this one's false. Okay, so you want to use truth table logic when you're looking at more than one condition. Okay, and that's what we're going to see. I'm going to show you guys how to write proper if-else statements, nested statements. They go in. They got something called chain conditions and stuff like that. So we'll go through all those. But come back to truth tables and learn your logic on how that stuff works. Okay. So I'm gonna close that. Let's go back into our Jupyter notebook. Or sorry. There we are. Okay. So first up, if x is greater than 0, and then we have a colon. Okay. The colon ends the line, and then everything inside tabbed over belongs to this if statement. So I could say print x is positive. Okay, and so nothing prints because I got to give x equals 7. Let's say. Okay, x is positive. Now, if you're from another language, what you're likely to see is something like that right there, and then depending, you might have opening and closing braces. Okay, again, Python does a good job getting rid of all the syntax so that you guys can run this stuff properly. Okay, let's see, so let's run an if-else statement. Okay, so if, we'll say if x modulus 2 is equal. Oop, and you know what? I forgot to put that on here. This is also a relational operator. Okay, equals. That's comparing to check to see if two variables are equal. It's just taking the relational operator is just taking the relationship between variables. Okay, so if x modulus 2 is 0, then print x is positive, else print, I gotta put my semicolon on there, or colon on there, else print x is even, odd. Okay. Okay, and let me show you how this is done. So let's say x is 5. Okay. Well, since the left side here is greater than that, then I check to see how many times does 2 go into 5. 2 goes into 5 2 times. 2 times 2 is 4. Subtract that out, I get a remainder of 1. Okay, so 5 is an odd number, whereas 6, if x equals 6, 2 goes into 6 3 times. 3 times 2 is 6. Sorry, 6. 6 minus 6 is 0, so remainder is 0. So 6 is an even number. Okay, so that's how you figure this out. Now, if I put 1 in there, 1 modulus 2, okay, the thing is just the left-hand side of the equation. So if this variable is less than this one, then the answer is just the left-hand side of your equation. Okay. Okay. So let's just test it out with a few different numbers real quick, so that you can see it. X equals 5. Okay, x is odd. 6. It's even. I don't know. 1,000. Even. 999. Odd. And let's just test our 1, just so that you guys can see it. 1 is odd. Okay, cool. So that's truth tables. We got our if-else statements going. Now we've got multiple if-else statements. Okay, so we got if x is less than y, print x is less than y. Elif, that's in the older languages, that means else if x is greater than y, you print x is greater than y. Okay, and if x isn't greater or less than, that must mean it's equal to. So I could say else print x is equal to y. Okay, so if I run this bad boy now, I get an error. Where's my error? Module. Name y is, okay, so let's just do this. We'll say x equals 5, y equals 4. Okay, let's see what happens. Okay, x is greater than y. Could switch them up. 4, 5. X is less than y, and then we could say x is equal to y. Okay, so you can have as many of these elif statements inside here as you want, depending on what you're trying to accomplish. But that stands for else if. Okay. Next, we get to nested loops. So I could have something like if x is equal to y. I could print x and y are equal. But then I could say else, and I could say if x is less than y, print x is less than y, else print x is greater than y. All right, so x see here, did I do something wrong? Else, invalid syntax. I think I gotta bump this over one. Try this. Okay, so if this is not true, then we do else, and then we can do nested if statements inside this else statement. Okay. Let me think here. All right, so you might not want to do this. You might want to do what we went through with our truth tables. You might want to say, you could have something like if 0 is less than x, you could say if x is less than 10, print x is a positive number, positive single digit number. Okay, so let's see here. X equals 5. So I ran that. X is a positive. Okay, so that kind of looks funky. You might want to take that, do something like this. You might want to get rid of that and say, and x is less than 10. Okay, and it accomplishes the same thing. So you're doing both of these. So you're running this one and this one inside one statement there. And then this actually does some cool stuff too, where you don't even need an and statement in here. Look at this. So you could just say, and I've never seen this in any other language, so this is pretty cool. You could say, and I get a lot of high school kids that write code out like this. Like in their mind, it makes sense, even though it's not right syntactically. So, but with Python, it works. Okay, so x is greater than 0 but less than 10 at the same time. Okay. Finally, and you know, this is going to be starting to be a big thing from here on out. Is I'm just typing this stuff in. Now you're going to be able to type in information as if you could type whatever you want. So we can input information. So let's say I say name equals input, and then I could type, what is your name? And I would print name, whatever I type in. So I can run this. And it says, what is your name? I type in Mike and press enter. And Mike, what I typed in, gets stored in the name variable, and it prints Mike right there. So that's going to be a big thing from a lot of the stuff we do. Okay. Let's see here. All right, so next up, let me open up. So this is the worksheet I am going to be working on right now, and I'm not going to do, again, like the last worksheet, I'm not going to do all of them. I've included the answers down here for everything here, and I'll go through a few of them. But this will be something that you want to work through and make sure you understand. there's just some simple programs in here that you guys can write and see if you understand it. But, I guess let's start off, and let me open my pen up for some sketch screen. Okay, so we want to know what prints to the screen, A and B. So A is A is 10 and B is 5. Is 10 less than 5? Nope. So this assignment statement right here does not run. Okay, and so all it does is print 10 and 5 to the screen. Okay. Let's skip down here. A and B is A is 10 less than 5. Nope. So it just prints 10 and 5 again. Maybe I'll do a bunch of these because next up is 10 less than or equal to 5. No. So because it's tabbed over, it belongs to this if statement. So since this is not true, okay, this doesn't get hit either. This comes down to opinion. In the old days when you had braces, to me it made it easier to see, but you're just going to have to remember that if this is tabbed over, it belongs to this if statement, okay? 4. A is greater than B, that's true. So B is 5 and C is 8. So that's 13. That is not less than A, so it must print 5 and 8 right here. Okay. We got to close this down. Let's scroll down to, let's just do the last 3 here, or last few. Let's see how many we want to do. Sketch screen. So, well, shoot, and I don't remember what A and B and all that were equal to. So, let me see here on my paper. Let's see if I printed this page out. Yeah, so let's do this. So A is equal to 10, B is equal to 5, C is equal to 8, and temp is 0. Okay, so A is not less than, so 10 is not less than 8. Else if 8 is less or greater than temp, that's true. You do A minus C, so A is 10 minus 8 gives you equals 2. So A is now 2. Okay, so you print 2, 5, and 8 for 6. Next up, A is not less, so 10 is not less than 8, so that skips that. Else, A plus B is, so C is equal to 15. If B, so that's 5, is greater than, so that is true, then A is now equal to, 5 plus 15, so that gives you 20. So, what is this? A equals 20. So it prints 20. B never changed, so B is 5 and C is 20. Okay. You can do 8 on your own. It's fine. This stuff is pretty easy. It's not like it's that difficult. Okay. Some truth table work. Let's look at this. So, evaluate the following expressions in the blank next to expression right, true or false. I might have screwed that up because you don't know what X or Y are equal to. Let me look here. Did I make a mistake on this document? No, I just didn't go down far enough. Sorry. Okay, so X is false. Okay, so false You got false, or you got true. So true and false, are both of these true? So that's false. So you got false or false is false. You got false and not true. What's if something's not true? It is, so if it's true but it's not true, then that would mean it's false. So false and false is false. So that side's false. So the only way to make it true with this side would have to be true. So you got false or, and you got not false is true, and true. True and true is true. So false or true is one or the other true. Yep. So that's true. Okay. Y, I'm going to just jump down here. I'm not going to do all of them. Y is true, so not true. That means it's false. Okay. So you might have something like this where you've got a Boolean expression and you want to evaluate, what does it say? The Boolean expression, this is true, and then figure out whenever it's true. So in order to do that, you'd say true, 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 false, false, true, false, false. So true and true or true is true. True or false is true. False or true is true, and false or false is false. Okay. One or the other of these is true. One or the other of these is true. One or the other of these is true, and one or the other of these true is not true. So it's false. So basically, you got true, and in this case, B is true. So true and true, they're both true. So the whole thing's true. In this case, you got true and false. That's false. This one you got true and B is true. So you got true and true is true. And you got false and B is false. So the whole thing is false. Okay. So when are these true? They're true whenever B is true, probably. Yep, because look at B is, wait, I screwed this up, I think. No, B is true here, B is true here. A is false here and A is true here, so the only time the whole thing's true no matter what is when B is true. Okay. Sorry, I'm making a video, so. Okay, so that's how you figure out these answers. Okay, let me scroll down. You guys can work on those. And now I think it's probably a good idea to write all these out for you guys to see how they work. So first one, smallest of three. Write a program that sets a variable to the smallest of three numbers. Enter three numbers and display the smallest of the three. Okay, so let's see here. So I've got num1, and that'll be equal to input. You know, whatever you guys enter, I'm just going to say enter number 1. Okay. Num2 equals input. Enter number 2. I got num3 equals input. Enter number 3. Okay, so you'll be able to type in the three numbers there, and basically if num1 is less than num2, and then you could check to see if num1 is less than num3, and so in this case the smallest would equal to num3, else the smallest is equal to wait. num1 is less than num2, num1 is less, so this would be num1. And then if num1 is not less than num3, since num1 is less than num2, then num3 has to be your smallest number. Okay. Else we got to go back here because num2, we got to check to see if num2, so if num1 is not less than num2, then we check to see if num2 is less than num3. And if it is, and we would need to say, sorry about that, else if, we would say smallest is equal to num2. And if that's not true, else the smallest would be equal to num3. And then we can print the smallest. Okay. So if I run this and I enter, what's wrong with this? Else line 8, 2, 3, 4, 5, 6, 7, 8. Needs colon on it. That's one thing I don't like about this, is it tells you what line you're on, but it doesn't tell you which line. So let's try this now. So enter. So I'll do 1, 2, 3, and the smallest one is 1. I could enter 3, 2, 1. Smallest number is 1. I could then enter 3, 1, 2, and that'll give me the smallest number there. So, all right, next program is going to be printing up the. All right, so for the next one, you're going to enter a season number, and based off of the season number, you'll print up whether the season is spring, summer, fall, or winter. So let's get back in here, and we could say season number equals input. Actually, you know what? We have to make it an int first, all right? Int input. Because if you don't, you got issues later on, I can show you. And then we enter 1 for spring, 2 for summer, 3 for fall, and 4 for winter. Okay. And you say if season number is equal to 1, season is equal to spring, else if season number is equal to 2, you got season equal to summer. If season number is equal to 3, then the season is equal to fall. And else, and I need to put colons on the ends of these. Else, season. Actually, let's do this. Because we'll put an error in. Else if season number equals 4 equals winter. You could say else. We could say season, and I need to make. We could say season is equal to error. You entered a number outside the range 1 through 4, and then we just print this, print season, and You know, I could enter 1. I could enter 2. That works. 3 and 4. That works. And then I can enter, let's try entering 5. 5, that gives me the error. Now let's go back real quick. If I did not make this an int, okay, and I run this, I enter 1, you entered a wrong number, because what happens is you're actually entering a string, and that string is being stored into season number. And so a string 1 is not equal to an int 1. Same with like a string 2 is not equal to a int 2. So in order to force it to be an int, you would cast it and turn it into an int while you enter it here, and everything will work properly for you. Okay, so that's the second one. Let's look at the third one real quick. Third one, using the following chart, write an if-else statement that assigns 0.1, 0.15, or 0.2 to commission, depending on the value in sales. We're not going to create a logic model for this. I'm not sure the book actually goes through logic models, but it's pretty easy to write. So basically we would have, we'll say tote sales, and we'll cast that as a float. And basically what that means is you know, your salesperson's gonna make so much money, and then we could say enter your total total monthly sales, and dash n. So if total sales is less than 10,000, then the commission, sales commission is equal to 0.10. Else if total sales, and sorry, I'm not going to call this elif, it's else if. I don't like saying elif. Else if it's greater than or equal to 10,000, and tote sales is less than 15, less than or equal to, sorry, I need to put that equal to 15,000, then the sales commission equals 0.15. Else, I keep forgetting to put the semicolons on. Sales commission equals 0.2. So then I can print the sales commission and run that real quick. So I could say, I don't know, $10. Sales commission is 1. I could say, let's do 10,000. So this should be 0.15 because 10,000 is greater than or equal to 10,000. What's it doing? I don't know. It's done. Doesn't want to compile. It works. Let's do one more and then we'll be done with this video. Last one. The marginal tax rate. Okay, so based off of what you make as a single filing tax earner, there's your tax rates that you gotta plug in. So, and this one's kind of overkill, so you should be good with this by now. But if int input enter your income, if income is less than 9,275, marginal tax rate, MT rate, I'm going to call it, is equal to 0.1. I'll write it out. It's because variables should be descriptive. If income is less than 37650. Marginal tax rate is equal to 0.15. If income is less than 91150. Oops, 90. Okay, okay, income is less than 415050. If you make more than that, and you can say print. All right, let's run this real quick. It's not running. Something wrong with it. I think I got to restart it. Let me see here. File. Close and halt. Let me see if I can open this back up so that you guys can see it. Conditionals. Hopefully it saved it. Run. Oh, it's not doing it. Either way, this is what it looks like. Oh no, there we go. Enter your income. Say 100,000. So that would put me at the 28% bracket. And it puts a percent symbol, and I'm not going to go through formatting decimal spaces, but anyway, it works. So that should take care of this chapter for you, and should be pretty easy. So we'll be done with this one.